Hello everyone. So today we are having a topic of class 10, that is types of reactions. Okay. Basically reaction is what? The breaking of old bond and the formation of new bond. As for example, if we take A2 as reactant and B2 as second reactant, we'll have the product 2AB, right? Or we can write like this, 2AB. So what happens here? This AA bond or BB bond breaks to form the AB bonds. So this A and BB bond breaks to give rise to this AB bond. So reaction is what? The breaking of the old bond and the formation of the new bond, so that we get the product. So we are having a different type of chemical reactions. Very first type of chemical reaction is combination reaction. So what is this combination reaction? When two or more than two substances, or we can say pure substances, combine with each other to give single product, then it is called as combination reaction. So students, here two key points are there. First is pure substances and other is single product. So always pure substances combine together to give rise a single product. Single product is characteristic feature of combination reaction. So whether it is element or compound, but it should be a pure substances. Clear? Now this is the general form of combination reaction. Means what? Any reactants, say A or B, combine together to give rise a single product, that is AB. Correct? Now we are having different types of combination reactions. Here I have taken three types of combination reactions. The very first type is element-element combination reaction. Correct? Means what? Two elements. What is that? The reactant are always in the form of elemental state in this type of combination reaction. So two elements combine together to give rise to a single product. Got it? As for example, here we have taken H2, which is in its elemental form, Cl2, chlorine, that gives rise to HCl. Right? Similarly, some more examples are there. Carbon, which is also in its elemental form, oxygen, which gives rise to CO2. Then magnesium plus oxygen, that give rise to MgO. Similarly, H2 plus O2, that will give rise to water. So there are so many examples of element-element combination reaction. So whenever two elements combine together to give rise a single product, then we call it as element-element combination reaction. Right? Now the second type is element-compound combination reactions. Means what? One of the reactant should be element and other should be product. So when one element combine with the other reactant which is in its compound form, then it gives rise to single product, then it is called as element-compound combination reaction. So here are certain examples of element-compound combination reaction. Very first is CO, that is carbon monoxide, plus oxygen gives rise to CO2, carbon dioxide. Clear? Similarly, water plus oxygen give rise to hydrogen peroxide, H2O2. Then PCl3 react with chlorine to give rise to PCl5. So you can write some more examples of element-compound combination reaction. Right? Now we are having the third type of combination reaction, which is compound-compound combination reaction. Means what? Both the reactant are in its compound form. Correct? As for example, CaO plus CO2 give rise to CaCO3, that is calcium carbonate. CaO plus H2O give rise to CaOH whole twice, that is calcium hydroxide. And one more example I have taken here so that you do remember, it's not like that only two reactants combine together. The number of reactant can be more than two, but the product should be single. That is the characteristic feature of a combination reaction. So here we have taken 3 reactants, CaCO3, H2O and CO2. And when all these reactants combine together, it will give rise to CaHCO3 whole twice. Got it? So basically we can write our short note like combination reactions are combination of pure substances. Second point is it always gives rise to single product. Third point can be its types. So its types are element-element combination reaction, compound-compound combination reaction and element-compound combination reaction. So just memorize it and write some more examples of these type of reactions. The second type of reaction is decomposition reaction. Now the decomposition reaction is just reverse of that of combination reaction. What was combination reaction? When 2 reactants combine together, it will give rise to a single product. So its just opposite form is the decomposition one. Means what? When single reactant splits into 2 or more than 2 products, then it is called as decomposition reaction. Correct? Now here I have written under suitable conditions. Means what? We require some amount of condition to perform the decomposition reaction. Do remember, it is always an endothermic reaction. Endothermic reaction. Why it is endothermic reaction? Because we need an agent. We need some amount of energy in the form of sunlight, heat or whatever the form is. But we need some amount of energy to perform the decomposition reaction. So it is the general form of decomposition reaction, that is AB, that is the reactants splits into A and B. So when single reactant splits into 2 or more than 2 products under suitable condition, then it is called as decomposition reaction, which is just reverse of the combination reaction. Now moving towards the types of decomposition reaction. We are having several types of decomposition reaction, and that is based on the source of energy which is needed to break down the reactants. Correct? Now the very first type is thermal decomposition reaction. Now what is this thermal decomposition reaction? The meaning of the term thermal is heat. The meaning of the term thermal is heat. So when we need or when we require heat energy to break down of reactants, then this is called as thermal decomposition reaction. Means when heat is the source to break down or to splitting the reactant into different product, then the decomposition reaction is termed as thermal decomposition reaction. As for example, FeSO4.7H2O, hydrated ferrous sulfate. Now this hydrated ferrous sulfates on heating give rise to FeSO4 plus 7H2O. Similarly, when we heat this ferrous sulfate, we have Fe2O3 plus SO2 plus SO3. So what happens here? This single reactant breaks into 2 or more than 2 products by the supply of heat. So whenever there is supply of heat and a reactant breaks into different products, then it is called as thermal decomposition reaction. Now the next one is photodecomposition reaction. Photodecomposition reaction means what? Here the source is photo, which is photon. It means light. Actually it means the sunlight, but here we, in the broad sense, we call it as light. So photodecomposition reaction. By the name it is clear that the decomposition takes place in the presence of light. Correct? So when the decomposition takes place in the presence of light, then it is called as photodecomposition reaction. Now here are several examples. 2AgCl in the presence of sunlight splits into Ag and Cl2. Similarly, AgBr in the presence of sunlight breaks into Ag and Br2. Now this reaction is very much important for your board examination point of view, because this is a question in many times this question is asked in your board examination, and also it is a question of your NCERT exercise. These two reactions are very much important because these two reactions are used in, earlier it was used in black and white photography. Clear? Now the third type of decomposition reaction is electrolytic decomposition reaction. Electrolytic decomposition reaction means what? The decomposition reaction which is in the presence of electric current. whenever the decomposition takes place in the presence of electric current, then that is called as electrolytic decomposition reaction. Here I have taken one example, water. When we supply electric current in that, it will give rise to 2H2 plus O2. So whenever a reactant splits into its products in the presence of electric current, then it is called as electrolytic decomposition reaction. Clear? Now, the fourth type of decomposition reaction is catalytic decomposition reaction. Means what? Whenever there is presence of catalyst and that help in decomposition, then it is called as catalytic decomposition reaction. Now, all of you know what are catalysts. Catalysts are the substances which alters the rate of reaction without consuming itself. So, whenever the reaction proceeds or whenever the decomposition reaction takes place in the presence of a catalyst, then it is called as catalytic decomposition reaction. Here I have taken the example of decomposition of ammonia. Ammonia gas under high temperature and pressure in the presence of a catalyst, platinum in its solid state breaks into nitrogen and hydrogen gas. So this is catalytic decomposition reaction. We just summarize the point. Decomposition reaction is that reaction in which single reactant should be there. Second, it needs some suitable condition. Third, it is always an endothermic process because it requires some amount of energy, and there are the types of decomposition reaction, that is the thermal, photo, electrolytic and catalytic decomposition. Now, moving towards the next topic, that is the displacement reaction. This is the third type of reaction. So, displacement reaction is what? Whenever the reaction takes place between one of the element and other compound, right? Then the more reactive element will displaces the less reactive element from its compound, and that compound is always in the aqueous solution state. In class 10, we have to study only about the metal-metal displacement reaction. In higher classes, you'll get aware about the metal-non-metal displacement reactions and so on. So here we basically focus on metal-metal displacement reaction. So your definition can also be changed as when more reactive metal displaces the less reactive metal from its metal salt solution is called as displacement reaction. Now how could you know that this element is more reactive or that element is more reactive? For that we are having a reactivity series. Now what is this reactivity series? This reactivity series is actually the arrangement of different metals on the basis of their reactivity. This series, you have to learn this series, just memorize this series. Here the most reactive element is potassium, then sodium, then calcium, magnesium and so on. The least reactive metal is platinum. Correct? Now, whenever there is a displacement reaction, higher reactive metals displaces the less reactive, or we can say lower reactive elements. As for example, we have taken here Fe plus CuSO4. Now see in the reactivity series where Fe and Cu lies. Fe lies just above the copper. It means what? Fe is more reactive than the copper. So in the displacement reaction, this iron displaces this copper from its metal salt. Right, and this iron takes place of this copper. So it becomes FeSO4 plus Cu. If you perform this experiment in your laboratory, this is also the part of your lab practicals. So when we perform this experiment in our laboratory, what will happen? We just take a beaker, then we add CuSO4. If it is in crystal form, then we have to add water to make it aqueous. Then we have to add Fe, and our blue color solution, that is of copper sulfate, changes into green color solution, which shows that this copper is displaced by this iron, and we get the Cu as its elemental form. Correct? Now, second one is very common example, that is zinc plus CuSO4 gives ZnSO4 plus Cu. Now here, just see, zinc lies here and copper lies here. Means what? Zinc is above the copper. That's why again zinc is more reactive than the copper. So it will displace the copper from its salt solution and takes its place. So it becomes ZnSO4 plus Cu. And when we perform this experiment, this blue color of copper sulfate changes to colorless solution of zinc sulfate. Correct? So in the displacement reaction, we have to memorize 2 or 3 things. Very first is the reactivity series. Without reactivity series, we are not able to perform the displacement reaction. Correct? So first you have to learn the reactivity series. That is the series, or we can say the order of reactivity of different metals. Second is, we have to remember that one of the reactant is in its elemental form and the other element should be always in its metallic salt solution form, right? And the one which is in elemental form is the more reactive metal, and the salt solution is the less reactive metal. When you want to just reverse this reaction, means what? ZnSO4 plus Cu, then don't write that it becomes CuSO4 plus Zn. This is an incorrect reaction. So whenever less reactive metal is there, it will not displaces the more reactive metal from its metal salt. So this reaction is not possible. Right? So one of the reactant should be in its elemental form, which is more reactive, and other should be in its metallic salt solution form. Clear? So you have to just learn the reactivity series to perform or to learn the displacement reaction. So displacement reaction is what? The reaction in which more reactive metal displaces the less reactive metal from its salt solution. So the next type of reaction is double displacement reaction. So here the term double displacement clarify that the displacement reaction occurs twice here. So whenever the displacement reaction occurs twice, then it is called as double displacement reaction. What is this double displacement reaction? The reaction in which one component each of both reacting molecule get exchanged to form the products is called double displacement reaction. Means what? 2 reactants are there and both reactants are in the form of aqueous solution. So the ion gets exchanged. Okay, the anion of one of the reactant get combined with the cation of other reactant, and the cation of other reactant combined with the anion of next reactant. So here we can see the general form. AB is one of the compound and CD is one of the compound. So what is the reaction here? A combined with D and B combined with C. So our product become AD and BC. Here we have taken several examples. First is BaCl2, barium chloride. Barium chloride react with sodium sulfate to give rise a precipitate of barium sulfate and NaCl. Clear? So barium sulfate is in precipitate form. That's why I use the downward arrow, right, which is a symbol of precipitate. The next example is HCl plus NaOH give rise to NaCl plus H2O. So what happens in both reactions? The ion gets exchanged. So whenever the ion gets exchanged in a reaction, that reaction is called as double displacement reactions. Clear? Now see this point. This is a very important point. Almost all precipitate reaction and acid-base reactions are examples of double displacement reaction. Here I have taken one of the example of precipitate reaction and one example of acid-base reaction. So whenever the acid-base reaction or precipitate reaction occurs, that is the example of double displacement reactions. So in the today's lecture, we just read about the different types of reaction. The first is combination reaction, then decomposition reaction, displacement reaction and double displacement reaction. In the next lecture, we'll continue with one more, a very broad topic that is a very important type of reaction, which is redox reactions. So that's all for this lecture. Thank you.